In question 15, it says, in the diagram below, quadrilateral ABCD is a rhombus with diagonals AC and BD intersecting at E. So, knowing that it's a rhombus and AC and BD are intersecting at E, we should draw in what we know about diagonals in a rhombus. We know that diagonals in a rhombus are perpendicular, which means that there are 90-degree angles being formed. Let's look at the next piece of information that was given. AB is equal to 3x, BC is equal to 5x minus 2, the measure of angle CDB is equal to 6y plus 10, and the measure of angle DCA is equal to 8y minus 4. Part A says, find the value of x. So locate in your diagram where there are x's. We have an x here and an x here. So looking at our diagram, we should notice that the x's are dealing with sides. What do we know about sides of a rhombus? We know that all 4 sides are congruent in a rhombus, which means this side right here is equal to that side, so we could set each expression equal to each other. 3x equals 5x minus 2, and from here we're just going to solve. So I'm going to subtract 5x, subtract 5x, that cancels out. We have negative 2x is equal to negative 2, and if we want to get rid of that negative 2, we're just going to have to divide, and x is equal to positive 1. The problem doesn't say what is the length of AB, what is the length of BC, it just says solve for x. So we did that, and we're moving on to part B then. Part B says find the value of y. So let's locate where there are y's in our expression. We have a y for this angle right here, and we have a y related to that angle right there. So if we look holistically at what these two angles are part of, we can notice that it's a part of this right triangle right here. So we're dealing with a missing angle, another missing angle, and we know that this angle right here is 90 degrees, and we know that all 3 angles in a triangle add up to 180. So we could set up our equation as so. So we have our first angle, which is 6y plus 10, our second angle, which is 8y minus 4, and our third angle, which is 90 degrees, formed by those diagonals in a rhombus, is equal to 180. On the left-hand side, we're going to combine like terms. So we have 6y and 8y, which is 14y. And then we have plus 10 minus 4 and plus 90. 90 and 10 is 100. Whoops, hold on. 90 and 10 is 100. And then we're subtracting 4. So we still have a positive 96 equals 180. From here, we want to solve for y, so we have to subtract 96, and 14y is equal to 84, divide by 14, and y is equal to 6. Again, go back to the problem, make sure you're not looking for a certain angle that you have to plug that value in. You just had to find y, so you're done with the problem. Okay. Number 16 says, using construction tools to create a scale drawing of triangle ABC with a scale factor of 2, use B as the center of dilation. So since they told you B is the center of dilation, we're going to take our ruler, and in this case I'm just going to use lines. So we're going to take our ruler, put it at B, and extend all the way through C. Take our ruler, put it at B, extend all the way through A. Now we're going to go back, and since B is the center of dilation, we're not moving that. I'm just going to draw a dot and call that B prime. All right, let's see how well this compass works. So we're going to put our needle on the center of dilation, and we're going to open it up so that we have the entire length from B to C. So this right here, that first marking, represents a scale factor of 1, but we want a scale factor of 2, which means we have to move it over, putting our needle at C and making another marking. Now we're going to do the same exact thing from B to A prime. Sorry about that. I'm not too sure where I left off because my husband came home and my dog was about to go crazy. So I paused it. So what I would have said was, since you moved C a distance of twice as further apart, we're going to mark that as a C prime. So from here, we're going to take our needle, put it at B, measure it to A, and mark it with a scale factor of 1. And then again, we have to go twice as big. So without moving the compass's opening, we're going to put our needle at A, make another mark for 2 times the distance, and call that A prime. So we took a triangle and we dilated it with a scale factor of 2, which means our final image has to be a triangle. So we have triangle A prime, B prime, C prime. For 17, we have, using the information given below, which set of triangles cannot be proven similar. So for similarity, we have angle, angle. We have similarity that's side, angle, side. And this is not talking about sides being congruent. We're talking about sides in proportion. Or there's similarity for side, side, side. So let's look at our pictures above. We have 12 and 4 as the corresponding side. So 12 and 4 is equal to 9 over 3. So we could go 12 divided by 4, which is 3, or 9 divided by 3, which is 3. Or we could say the cross products should be equal. So 12 times 3 is 36. 9 times 4 is 36. Either way, that works out. And we can't forget about our angle that's included. So that is good by side, angle, side similarity. Our next picture talks about angle and an angle. So we have one angle and this angle congruent to that angle. So by angle, angle similarity, that's good. So choice 1 and 2 cannot be the correct answer. Now we're going to look again at 2 given sides and an included angle. So 8 over 1 is equal to 16 over 2. So again, we could either do 8 divided by 1 to get 8 and 16 divided by 2 to get 8. Or we could check the cross products. 8 times 2 is 16. 16 times 1 is 16. That's good by side, angle, side similarity. And then that means choice 4 must be the way in which we cannot prove it similar. So let's check. 10 over 5 is equal to 12 over 7. We know 10 divided by 5 is 2, but 12 divided by 7 is not 2. Or the cross products we could check. 5 times 12 is 60. 10 times 7 is 70. They're not equal, therefore that is not the correct answer. And for 18, based on the diagram shown, is triangle ABC similar to triangle DEF, and we have to justify your answer. So let's look at our mappings. We have AB, which is 3. It corresponds to side DE. We have BC corresponding to EF. And lastly, AC corresponding to DF. So you should notice that we're given 3 sides in both triangles. Therefore, to check if they're similar, we want to use side, side, side similarity. And if it's similar by side, 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 that means the proportions simplify to the same number. So we're going to take the left triangle first. It doesn't matter which way you set up your proportion. So I'm going to say 3. So purple over purple is equal to green over green, which is equal to blue over blue. So from here, I'm going to say 3 over 6 is a half, 5.5 divided by 11 is a half, and 4.5 divided by 9 is a half. So yes, those triangles are similar by side similarity. You could have set the proportion up the opposite way by saying 6 over 3, 11 over 5.5, or 9 over 4.5, and then you just would have gotten 2 is equal to 2, which is equal to 2. The setup for the problem is not necessarily important here in the sense of which one you put up top and which one you set on the bottom, because they didn't say which one is the pre-image and which one's the new image. We just want to know if they are similar.